Hello and welcome to Excel Victory Academy, where math is made easy. Today we'll be looking at logarithm of numbers. Here we have the following questions. Evaluate the following using logarithm table. The first one, we have the square root of 3.435 times 45.3 divided by 1.025. Here's the second one, 31.95 raised to the power of 3. The third one, we have the cube root of 7,294 over 63.85. And lastly, we have the square root of 61.73 squared divided by 38.27 cube. Now, strictly we are going to address these questions using the logarithm table. And when you check your four-figure table, there is a section of it devoted to logarithm of numbers, and then next to it you have the anti-logarithm of numbers. That is a table that we'll be using in addressing these questions. So for the first question, for the first one, we have the square root of 3.435 multiplied by 45.3 divided by 1.025. So to begin with, we extract the numbers in our table like this, the numbers to the left and the logarithms to the right. So first we have 3.435. The second one we have 45.3. And the characteristic for the first number here is 0. That is, expressing this in standard form, we already have only one integer to the left before the decimal point. But for the second one here, 45.3, the characteristic will be 1. That's how to obtain the characteristic part. The second part is known as mantissa. And for us to get the mantissa, we'll strictly get that from the logarithm table. So when you look at this question, we're going to apply 3 different laws. First, we'll begin with the multiplication law, which is what we have here in the numerator. Next, we'll proceed to the division. And lastly, we'll apply the root law. And the multiplication law of logarithm states simply, if you are multiplying numbers, you add their logarithms. If you are dividing, you subtract their logarithms. That's for the division law. Then for the root, if you are finding the root of numbers, you divide the logarithm by the value of that root. In this case, we have the square root. So after finding everything here, the logarithm of all that we have here, we are going to divide it by 2. If we have cube root, for instance, we'll divide it by 3. If we have fourth root, we'll divide it by 4, and so on. Then lastly, when you look at this question number 2, for instance, we have power of 3. In this case, after finding the logarithm of the number, you multiply the outcome by 3. So those are the rules that we need to have handy in addressing any question in logarithm. Now, the first thing we need to do here is to check for 34 under 3, difference of 5. For logarithm of numbers, we begin from 10 to 99. Under 0 to 9, and then difference of 1 to 9. While anti-logarithm begins from 0.00 to 0.99. And also the differences from 1 to 9. So we are going to check for 34 under 3, difference of 5. These are logarithm table. So we need to check for 34 under 3, difference of 5. So 34 under 3, this is 34. Under 3, we have 5353. Difference of 5, difference 5 here we have 6. So we'll add that 6 to 5353 that we have here, and that gives us 5359. That's how to check for logarithm of numbers. The first thing you do, check for 34 under 3. You move to the difference section, and the difference is under 5. So under 5, you're going to have 6. So you add the difference to what you have here, and that gives you the logarithm of that number. 34 under 3, difference 5, we have 5359. The same thing will proceed to the second one, where we'll be checking for 45 under 3. In this case, there's no difference. So 45 under 3, we have 6561. 6561. That is 45 under 3. Here is it. 45 under 3. You have 6561. Next, we apply the first law of logarithm in this case, which is the multiplication law. And according to the multiplication law, we are to sum this up. So we have 9 plus 1 giving us 10. That's 0. You take 1. That 1 plus this 5 is 6. 6 plus 6, we have 12. So we are writing 2. We take 1 to this side. 1 plus 3 is 4. 4 plus 5, we have 9. 5 plus 6 is 11. So we write 1 and take 1 over to this side. And finally here is 2.1920. This, we label it as our numerator. This is our numerator. So for the second one, which is 1.025 here, 1.025, the characteristic is 0 because it's already in the standard form where you have one integer to the left. So we have 0. Next is for us to check for 10 under 2, difference of 5. 10 under 2, difference of 5. We are going to have 0, 1, 0, 7. Reason, when you check for 10 under 2, you are going to have 0086. 0086 is a difference 5 that gives us 21. So when you add 21 plus 0086, you are going to have 0107. Here is it. 10 under 2, you have 0086. Right? Then difference of 5. Difference 5 here, you have 21. When you add this 21 to this 0086, you now have 0107. So that's how we got the logarithm of 1.025 to be 0.0107. This is now our denominator. These are denominator. And when you have a fraction in logarithm, you have to subtract the logarithm of the denominator from that of the numerator. So we are going to subtract 0.0107 from 2.1920. And doing that, we are going to have 2.1920 minus 0.0107. We will have 3181.2. That is 0 minus 7 cannot, so we are taking 1 from here. Make this 10. 10 minus 7, we have 3. We have 3. We have 1 here. 1 minus 0, we have 1. 9 minus 1, we have 8. 1 minus 0 is 1. And 2 minus 0, you have 2. So this is what we have when the logarithm of the denominator is subtracted from that of the numerator. Next, we apply this root law on this number 2.1813. And like I said earlier, anytime you have the root sign, you are going to divide the logarithm by the value of that root. And the value of this root is 2. That's square root. So you are going to divide 2.1813 by 2. And when you divide this by 2, the result is 1.0907. We have 0907. So for antilog, we are going to consider only the mantissa part. That's 0907. It is when you are finding logarithm of numbers that you consider both the characteristic and the mantissa. In this case, we found 34 under 3 difference 5. That is including the integral part 3. The same thing here, we found 45 under 3. But when it comes to antilog, this integral part is not applicable. We make use of the mantissa part, and the mantissa part here is 0907. So for antilog, we are going to check for 09 under 0 difference of 7. This is possible because for antilogarithm table, we begin from 00 to 0.99. So after 00, you have 0.01, 0.02, 0.03, all the way to 0.99. Whereas in logarithm table, you begin from 10. Right? So that is why we cannot neglect this integral part when finding the logarithm of number, because we don't have anything like 0.0, 0.1, point this in logarithm table. It's only possible in antilogarithm table. So for antilogarithm, we are going to check for 09 under 0 difference of 7. Here is our antilogarithm table, and 0.09 under 0 we have 1230. Difference of 7, when you come to this difference of 7, you have 2. So adding these 2 to 1230, you are going to have 1232. Antilogarithm of 09 under 0 we have 1230. Difference of 7 we have 2. And summing these up, we have 1232. So this is our answer. Expressing this in standard form, we're going to have 1.232 multiplied by 10. We'll raise it to the power of the integral part of the number we used in finding the antilog, and that's equal to 10 raised to the power of 1. It's from this point now that we have 1.232 times 10 raised to the power 1, giving us 12.32. So this is the answer we are looking for. So anytime you are asked to find or evaluate a given number using log table, first of all, arrange it in this table, bring the numbers to the left, and then the logarithm of those numbers to the right. First, find the characteristics of those numbers. That is the integral part. And for this one, we got 0. For this one, we got 1. Then for you to get the mantissa is that part after the decimal point. You use logarithm table. So we check for 34 under 3 difference of 5 to get this. 45 under 3 to get this. Since in the numerator you have the multiplication sign there, you apply the multiplication law in which you are expected to sum their logarithms. Then you proceed to finding the logarithm of the denominator. At this point, 10 under 2 difference 5, we got 0.0107. Next, you proceed to the second law, which is now the division law of logarithm, in which you are expected to subtract the logarithm of the denominator from that of the numerator. We did that and got 2.1813. Lastly, we applied the root law. And in this root law, we have square root. For this particular question, we have square root, so we needed to divide by 2. Dividing by 2, we got 1.0907. At this point now, we'll proceed to finding the antilogarithm of the numbers, and 09 under 0 we had 1230. Difference of 7 we got 2. Summing these up, we have 1232. And lastly, expressing our answer in standard form, we have 1.232 multiplied by 10 raised to the power of 1. Take note, the power of 10 is always the integral part of the number you got. That is the logarithm that you finally got before proceeding to the antilog stage. So multiplying 1.232 times 10 raised to the power of 1, we got 12.32. For the second question, 31.95 raised to the power of 3. Question number 2, we have 31.95 raised to the power of 3. In this case, we are going to apply the power law. And in power law, after finding the logarithm of the number, you multiply the logarithm by the power you have there. So in this case, after finding the logarithm of 31.95, we'll multiply the outcome by 3. So first, we have our number and log respectively in this table form. 31.95 raised to the power of 3. The characteristic here is 1. So we'll check for 31 under 9, difference of 5. And when you check for 31 under 9, difference of 5, you are going to have 5045. So it is this 1.5045 that will now be multiplied by 3. Don't make that mistake of finding the cube of this number before finding the logarithm. No. First find the logarithm of the number 31 under 9, difference 5, before you multiply the outcome by the power, in this case 3. And 1.5045 multiplied by 3, we have 4.5135. Now we can proceed to finding the antilogarithms. Finding the antilogarithm of 4.5135 antilog. Again, we are going to make use of only the Mantiza part, which is 0.5135. Thereafter, we'll raise it, when we are expressing it in standard form, we'll raise the power of 10 to 4. So here we are going to check for 51 under 3, difference of 5, using our antilogarithm table. 0.51 under 3. Here we have 0.51 under 3. You have 3258, right? And difference of 5 here, we have 4. So here, 0.51 under 3, we have 3258. Difference of 5, we got 4. So when we sum this up, we have 2, 6, 2, 3. So we have 3,262. So it is this number now we'll express in standard form. So finally we are having 3.262 multiplied by 10 raised to the power of the characteristic that we have here. That is power of 4. And finally, we will have 32620 as our final answer. So this is how to find the logarithm of numbers using logarithm table. In this, so far we've looked at 4 different laws. The multiplication law, in which you are to add. the division law in which we subtracted, the root law in which you divide, and the power law in which you multiply the logarithm by the power. So let's proceed to solving the third and the fourth question. The third question, the cube root of 7,294 over 63.85. We have first of all a number, and then here we have log. For the first one, we have 7,294, and the characteristic here is 3. If that's expressing this in standard form, we only have one integer. So we need to move this 1, 2, 3 before we get to that one integer to the left. For the second number, we have 63.85. And in this case, the characteristic is 1 because the decimal point is here. Expressing it in standard form, we'll have 1. And since this is division, we're going to subtract their logarithm. So we have this minus sign here. Checking for 72 under 9, difference of 4. We have 8, 6, 2, 9. Also 63 under 8, difference of 5. We have 8, 0, 5, 1. Subtracting this, 9 minus 1, we have 8. 2 minus 5 cannot, so we take 1 from here, making this 12. 12 minus 5, we have 7. We have 5 here left. 5 minus 0, we have 5. 8 minus 8 is 0. 3 minus 1, we have 2. So it is at this point now we proceed to applying this cube root. And applying that cube root, simply we are going to divide this by 3. And when you divide 2.0578 by 3, the result is 0.6859. It is at this point now that we'll find the antilog. So the antilog of this number, antilog of 0.68 under 5, difference of 9. 0.68 under 5, difference 9. We are going to have 4842. Difference of 9, we have 10. This is it here. 0.68 under 5, we have 4842. When you come to difference of 9, we have 10. So back to our working page. 4842, that's 4,842 plus 10. We have 4,852. From this point now, we can find or express the answer in standard form. Expressing this in standard form, simply we have 4.852 multiplied by 10 raised to the power of the characteristic here, and the characteristic here is equal to 0. And from indices, any number raised to the power of 0 is equal to 1. So 10 raised to power 0, we have 1. 1 times 4.852 gives us 4.852. So this is the answer for the third question, in which we were asked to evaluate using logarithm table the cube root of 7,294 over 63.85. Lastly, for the fourth question, we have the square root of 61.7 73 squared divided by 38.27 cube, and we are to solve this or evaluate this using logarithm table. So the numbers here, we have 61.73 squared, and the second one we have 38.27 cube. So according to the law of logarithm, we'll first find the logarithm of this number before we apply that power law by multiplying the outcome by 2, and in this case by 3. So the characteristic of 61.73, we have 1. Also, the characteristic of 38.27 is 1. And since it's division we have here, we are going to subtract their logarithm. So the logarithm of 61 under 7, difference of 3, we have 7905. We'll multiply this by 2 because of power 2 that we have here. And for the second one, the logarithm of 38 under 2, difference 7, we have 5829. We also multiply this by 3. And when you multiply 1.7905 by 2, you are going to have 3.5810. And for the second one, 1.5829 multiplied by 3, we have 4.7487. It is at this point that we will subtract. So subtracting this denominator from the numerator, we have 0 minus 7, which is not possible. So we take 1 from here, making 10. 10 minus 7, we have 3. What we had here left is 0. So we take over 1 from here, making it 10. 10 minus 8, we have 2. We had 7 left here. 7 minus 4, we have 3. 5 minus 7 is not possible, so we take 1 from this integral part, making it 15. 15 minus 7, we have 8. Here we have 2 left. 2 minus 4, that gives us minus 2. And in logarithm, that minus 2 is written as bar 2. So what we have here is bar 2.8323. At this point, we'll now proceed to applying the root sign here. And the root that we have here is square root. And for us to apply it, we divide this by 2. That's the value of the square root over there. And that implies bar 2.8323 divided by 2. And when you divide by 2.8323 by 2, we are going to have bar 1.41624 decimal place. Because when you divide this, you are going to have 1.41615. But to 4 decimal place, we have 4162. At this point, we now find our anti-logarithm. The anti-log will be equal to, we'll check for 0.41 under 6, difference of 2. 0.41 under 6, we have 2606. Difference of 2, we have 1. And that sum up to give us 2607. Expressing this final answer in standard form, we have 2.2607 607 multiplied by 10, raise it to the power of the characteristic we have here, which is bar 1. Bar 1 is same as minus 1. So 2.607 times 10 raised to the power of minus 1 is same as 0.2607. So this is the final answer to this question number 4, where we were asked to evaluate using logarithm table the square root of 61.73 raised to the power 2 divided by 38.27 raised to the power of 3. So you see that in each case, we move a step at a time. You first find the logarithm of that number. Where you have division like we did have here, you subtract their logarithms. Where you have multiplication like we did have in example 1, you add their logarithm. Where you have powers like you did have power 2 and power 3 here, after finding the logarithm of the number, multiply the outcome by 2 and 3 respectively like we did have here. Anytime you have root associated with that number, you divide. For square root, you divide by 2. For cube root, like we did have in example 3 here, we divide by 3. So that's all about logarithm of numbers using log tables.